Okay, everybody, here we go. We're going to kind of get started here. Uh, this is stuff we've already done in class. You've seen your mission objectives for the day that you can apply Newton's third law to design a solution to a problem that involves the motion of two colliding objects. And we've seen the do now, the ISN, and this was your do now for the day. If you didn't know what the answer is acceleration. Okay, in class, you were given these two foldables to do. And if you did them correctly, I'm going to show you the answers. But they should kind of be in your notebook just like that. Why did I do that quick? So you don't try to catch the answers because these are due first thing in class on Tuesday. All right, so we're talking about Newton's third law of motion. So these are things that you already know, that for every action there's an equal and opposite reaction, that this known as Newton's third law of motion, and that in Newton's laws, move myself up out of the way so you can see, and there's always action reaction pairs. You see here that the book is on the table and the table's on the book. There's pressure from the table on the floor is exerting force back, and you can just go down this entire list and see how things go. So the two forces are in a pair, and they're called action reaction. So if you have one, you have the other. And if you know the strength of one, you know the strength of the other since they're equal. So if it had a strength of 10, then you also, the reaction force has a strength of 10. So the baseball pushes a glove to the left, the glove would push back to the right. A bowling ball pushes the pin to the left, the pin pushes back against the bowling ball to the right. It's kind of real easy. The exhaust pushes down, the rocket pushes up. So it's really kind of easy to see how all those forces work. So let's look here. Identify the two pairs of action reaction forces. Use the notation foot A, foot C, and ball B in your statements. All right, so as we look at this here, we can draw a little bit. You see that here is foot A, and it's pushing this way. Let's change colors. And foot C is pushing this way. So what does that mean for C? So we're going to take this back out. It's not exactly a science yet, but hey, we'll go. So the answer would be that the first pair of action reaction pairs, foot A pushes ball B to the right, and the ball pushes foot A to the left. The second pair pushes the foot C to the ball to the left, and it puts back to the right. Again, you can see this. It's in your notes, and you should be taking these pictures down and kind of keep up with where you are. So Newton's third law plainly states that for every action, there's equal and opposite reaction. It has to be equal in strength and opposite in the direction. Action reaction forces act on different objects, not on the same object. And they don't cancel each other out because they act on different objects. So Newton's first two laws talk about one object. The third law talks about two or more objects. So look here. What is the action and reaction forces present when a hammer hits the nail? If the force that the nail exerts on the hammer is equal to the force of the hammer exerts on the nail, what are we missing here? We're missing a piece. Why doesn't the nail remain at rest here? Well, let's do this to make it a little easier to see. Let's move me out of the way again. And let's change this, make it a little easier for everybody to see, to 18. There. Makes it a little easier to see. So, okay. So pause the video. After you pause the video, start and write down what you think your answer is. Then let's see where we end up. So take a moment, pause the video. All right. You don't have to worry about that. So, astronauts go on spacewalks when they need to do work on their space shuttle, perform accident experiments. How can they begin their motion if there's nothing? Let me get my picture here out of the way. It's a little bigger than what I meant for it to be. So how do they begin their motion if there's nothing for them to push on? So I want you to pause the video for a moment and think about that. All right, pause the video. Okay, we're back. So how do they do that? There's nothing for them to push on. So what do? Well, one thing they can do is they can push the rocket. They want to go to the right. They shoot a rocket or a burst of propulsion to the left, and it puts them to the right, and vice versa, up, down. So they go something in the opposite direction. So here's what I want you to think about. Driving down the road, a firefly strikes the windshield of a bus and makes quite an obvious mess in the front of the face of the driver. This is a clear case of Newton's third law of motion. The firefly hits the bus, and the bus hits the firefly. Which of the two forces is greater, the force on the firefly or the force on the bus? I want you to come tomorrow in class prepared to think about it. Okay? So I'll see you tomorrow. Look at the rest of the links on here for the remainder of your homework tonight. All right? See you tomorrow.